Let's talk about pointers in expressions. So if you look at the code I have here, we're going to be going over lines 24 through 36, possibly coding more. So first off, we have an array right here. It's a pretty simple array, holds 3 values, and then we have a second part right here. Well, what is this second part? The val pointer is going to declare a pointer to an integer named val pointer. The asterisk means that it's a pointer, so it's an array type, right? Because it's only separated with a comma. And it's a pointer because of the asterisk, and it's pointing to val pointer array. It's essentially declared but uninitialized, so nothing is inside of it until we hit this next line where we're setting the val pointer equal to vals. Notice how we don't have an asterisk in front of here? That's because we're just setting the array, the actual array part, not the pointer, to the vals array. So now our val pointer is going to contain 3 integers, the same integers as our vals. On the right, I have the run of what we have printed out here so far. So first I have a cout where I'm printing our asterisk val pointer. The output that we're going to be caring about is this down here. Everything else is from a previous example that we did with pointers. So I have our asterisk val pointer. It's going to print out the 4. That's important. You need the asterisk in front of this to print out the value. And then I have another example where I have the asterisk in front. And then what if we add something to our val pointer in parentheses? Well, what we're doing here is if we add to the val pointer without the asterisk, pretend the asterisk is not even there, all we're doing is going through the indexes. So if we add 2, it's going to be at the 3rd index, so printing 11. If we have the asterisk out front, we then print this value, which is how we get 11 here. Next, we have the same example, but without parentheses I wanted to show you. So we're going to have val pointer with the asterisk. That's just going to get our val pointer, which is pointing to the front. So it's going to give us 4. We're going to have 4 plus 2. And that will give us 6. So that's how we can manipulate these differently in their values. And now we just have a basic val pointer. Again, this should just print out 4. So you can see that nothing has changed inside of here. We have this val pointer plus equals 2. Now, what does this do? This is just going to add 2 to the index which we are at for our val pointer. So we are at index 0. We're now going to move up 2. So we're officially going to be at 11. And it's not going to stay at 4 once we do that output. It's going to stay at the 11 index and keep printing this value. I'll show you that in a second. It's because we're setting it plus equals 2 and not just a plus 2. So we have the cout, we're printing our val pointer without the asterisk, so it's going to print the address. And then let's print our actual val pointer with the value. That's going to be 11. And notice how I have this plus plus here. You can do plus plus and minus minus operations. That's going to move our val pointer. However, since this happens after our val pointer is executed, it's still going to print 11 because again, that's after. If we do a cout and we do a val pointer, make sure you have the asterisk, otherwise it's going to print address of it, and we'll just do end line. Let's try to run this again. While this runs, we can look at this bottom part right here, cout val pointer minus vals. What this is essentially doing is it's going to get us the difference in positions. So val pointer is now at this position, and vals starts at the 0 position. So we are going to have a difference of 3. Val pointer minus vals, that is 3. You can see after we did this plus plus, I print out a 0. Why is that? Well, it's because it moves out of the bounds of the array. So it's not going to print anything that's in our array. If instead we did minus minus, remember how this was previously 11 on this run from this val pointer right here? Well, after we do this minus minus, it's going to go down 1 index, and you can see now it prints out 7. And you can see the difference once we did the val pointer minus vals and print that out is only 1. And this other one, it was 4 because, well, we incremented it 1. You can see there's a ton of ways you can manipulate pointers, how you can have a pointer set to an array and completely go through it this way. It's a great way if you want to do something to your array and have it referenced but not modify it. It's also a great way to allow you to work with memory addresses directly. Since this is a higher level language, you don't have direct access to the memory unless you use pointers, and then you can get the addresses and you can manipulate them. So again, remember your asterisks when you're having your pointers. That makes sure that the compiler program knows that it's a pointer. You can set it equal to some array, and then you can just print that. You can increment through it. You can add it to the value at the index. You can adjust where the start of your pointer is going. You can increment it, you can decrement it, you can also get the address, and you can find the difference of positioning. All this is possible with pointers and expressions. If you have any questions about it, I know this might be a little bit tricky, so maybe rewatch again or leave a comment below. And if you want more C++ pointer and other videos, check out that playlist link below the like button.